Public campuses across Rajasthan are facing.
We present HEMS, the Hybrid Energy Management System, developed by Team Neurono. HEMS is a smart solution that functions as a campus-level virtual power plant to optimize renewable energy generation, storage, and consumption. So, how does it work? HEMS collects real-time data from diverse sources like solar, wind, and batteries. Next, using advanced deep learning, it accurately predicts energy and weather. Then, our smart optimization system makes real-time decisions to minimize grid dependency and cost. Finally, everything is displayed on a simple Power Views dashboard, leading to optimized energy use across entire campus. We have modular vendor neutral design using open standards like IEC 61850 and MQTT, ensuring flexibility and long-term maintainability. It's our cutting-edge technical approach. We use advanced What makes HEMS unique? It's our cutting-edge technical approach. We use advanced model predictive control with mixed integer programming for dynamic real-time decision making. Our system uses deep learning models like LSTM for highly accurate load forecasting. And it's also built on a modular vendor neutral design using open standards like IEC 61850 and MQTT, ensuring flexibility and long-term maintainability. We have also planned for potential challenges. While real-time optimization can be computationally intensive, we leverage scalable cloud platforms to handle the load. Our vendor-neutral protocols make integrating with older campuses devices seamless. This solution is not just innovative, it's feasible and financially viable, targeting a return on investment within 6 to 12 months. It also meets Rajasthan's energy needs for 100 plus institutions aligned with 2030 goals. Our architecture reduced deployment cost by 20% per site. Now, what are our sustainability goals? We will make sustainability appeal of carbon reporting 0.7570 CO2 per MWH attracts green funding. Now, what are the impacts and benefits? The impact is significant and measurable. With HEMS, campuses can reduce their dependency on grid by 20 to 30%, cut annual electricity cost by an impressive 15 to 25%, and slash carbon emissions by 0.757 tons for every megawatt hour used, helping India achieve its 2030 sustainability goals. It avoids RERC grid export penalties, ensure accurate bill auditing. It also promotes renewable integration, strengthens Rajasthan's grid resilience. Now, in the end, conclusion. HAMS is more than just software. It's a complete solution for smarter, greener Rajasthan. It ensures compliance with RERC policies, enhances grid stability, and is ready to be deployed across more than 100 public institutions, amplifying statewide energy efficiency. We are Neuronodes, and with HMS, we are building future of sustainable energy management. Thank you. This is the main dashboard of our prototype. This is the main dashboard of HEMS. This shows total energy generation of campus, total energy consumption of campus, battery level of representing energy generated by solar, wind and grid across whole year according to the months. This is the represent demand versus forecast report of our campus. This is the graph presents real-time energy flow. Currently, solar panels are using 1.2 gigawatt of energy, wind turbines are using 800 megawatt, and main grid is using 50 megawatt. This is the battery storage of our device, and this is the total energy consumption of our campus buildings, 2.05 gigawatt. Now, forecast report. Here we will choose our file in CSV format. We will upload it and it will generate forecast reports. And I have made three individual reports for solar generation, wind generation, and energy demand. Through this, we can get an idea of separate energy reports. Now, here I have made one section of optimization. Now, what does this do? How does it works? So, currently I have used kilowatt in forecasted solar energy, 3000 kilowatts. For example, currently in forecasted wind energy is 350 kilowatt. Now, total forecast will be 4350, 4350. Now, our demand of energy is 5000 kilowatt. Assume that this is the current energy level and current energy price. Now, by these recommendations, this and it will gives us alerts regarding surplus energy or deficit of energy. This is the battery charging report. What I have seen, what I have entered that 400 plus 350, 4350. As our demand of energy is 5000 kilowatt and we are currently generated 4350 kilowatt. So 650 kilowatt of energy deficit is expected. Now, battery will discharge immediately to cover 650 kilowatt energy deficit and reduce reliance on grid. Now, we will take another example. Here I will take 3000 solar energy and 500 wind energy and 3000 kilowatt. Assume that. Then also alert is generated. This is the surplus energy alert. Now, as you have seen, our forecasted solar energy is 3000 kilowatt and forecasted wind energy is 500 kilowatts. So, 500 surplus energy is anticipated. Now, we will prioritize battery charging and explore opportunities for increased non-critical loads consumption. Now, here we will take zero wind energy, 3000 kilowatt solar energy and 3000 is expected demand. Now, observe the recommendations. Here it is showing delay charging. Solar energy meets current demand and the battery level is sufficient. It will monitor for future price drops or higher renewable output. It will hold the charge because demand is currently met by solar generation and grid prices are not at a peak. Now, this is the alert menu. These are all the alerts which have been shown on alert menu. For example, high grid dependency, if battery level is critical, if wind generation is surplus, etc. I have made separate summary section for all the alerts. This will generate summary of alerts to review and manage our system. Now, this is the settings menu for managing profiles. Now, we have designed system for high dignitaries in college. So, to able to use it, you have to select role. Currently, we have used three managerial positions: system operator, facility manager, and researcher. These three can only use this system. This is the battery level percentage. After 20%, it will show alert. And if grid power exceeds 500 kilowatt, it will show alert. This is a smart notification system where you will receive notification in the form of email for all these alerts, etc. Thank you.